It's science time, and today we will be learning about, you guessed it, science, or more specifically, energy and motion. In this movie, we will learn about energy and motion in our everyday lives. Then we will conduct an experiment where we change the gears on a bike and see how it affects speed and other factors. But before we do that, let's learn more about energy and motion. There are two types of energy, kinetic and potential energy. Kinetic energy is the energy of motion, and potential energy is stored energy. A good example of these energies is the energy on a swing. When a person is on the top of a swing, the potential energy is greatest, but when the swing is closest to the ground, the kinetic energy is greatest. The swing is like a pendulum. In the absence of friction, it would swing forever. There are 6 types of potential energy. The first is gravitational energy. This energy causes objects to be attracted to the center of the Earth. The next one is electrical energy. This energy is found in batteries. Next is chemical energy. Humans get chemical energy from the food we eat. Next is thermal energy. Thermal energy results in a change in temperature. Then there is magnetic energy, which is found in attracting and repelling magnets. Elastic energy can result from things like slingshots and rubber bands. Energy and motion are a part of our everyday lives. If we didn't have energy, we couldn't survive. From the time we get up in the morning to the time we go to bed, and even while we sleep, we use energy. We get this energy from the food we eat.
The experiment. For this experiment, we'll slowly increase the gear, decrease the IMA of a bike, and calculate different variables. Our subject, Sam, will bike 7 meters for each gear test. To factor out the unreliability of the start time, Sam has 2 meters to start biking before I start timing. Then we'll find the weight in newtons and use the weight equation to find the mass. For our calculations, we will find the speed, velocity, energy of the bike, kinetic energy, and momentum. The equations I will use are the following. My hypothesis is that a decrease in ideal mechanical valence, or increase in the gear, will increase the speed, velocity, kinetic energy, and momentum, but will not affect the energy of the bike. Note, the gear of a bike and the IMA are inversely related. A high gear like 7 has a lower IMA than a lower gear. Calculations Gear 1, IMA 0.38, speed 3.9 meters per second, velocity 3.9 meters per second, energy 720 quadrillion joules, kinetic energy 590 joules, momentum 300 kilograms times meters per second. Calculations Gear 2, IMA 0.33, speed 4.1 meters per second, velocity 4.1 meters per second, energy 720 quadrillion joules, kinetic energy 660 joules, momentum 320 kilograms times meters per second. Calculations Gear 3, IMA 0.32, speed 4.4 meters per second, velocity 4.4 meters per second. Energy 720 quadrillion joules. Kinetic energy 760 joules. Momentum 340 kilograms times meters per second. Calculations Gear 4 IMA 0.28, speed 4.7 meters per second, velocity 4.7 meters per second. Energy 720 quadrillion joules. Kinetic energy 860 joules. Momentum 370 kilograms times meters per second. Calculations Gear 5 IMA 0.25, speed 5 meters per second, velocity 5 meters per second. Energy 720 quadrillion joules. Kinetic energy 980 joules. Momentum 390 kilograms times meters per second. Calculations Gear 6 IMA 0.21, speed 5.4 meters per second, velocity 5.4 meters per second. Energy 720 quadrillion joules. Kinetic energy 1,100 joules. Momentum 420 kilograms times meters per second. Calculations Gear 7 IMA 0.19, speed 5.8 meters per second, velocity 5.8 meters per second. Energy 720 quadrillion joules. Kinetic energy 1,300 joules. Momentum 450 kilograms times meters per second. Final results. From this experiment, I learned many things about the relationship between IMA and other factors of motion. Speed. IMA and speed are inversely related. A decrease in IMA increases the speed. Velocity. An IMA and velocity are inversely related in the same way that IMA and speed are related. Energy. The energy of bike remains constant despite the change in IMA. Kinetic energy. The decrease in IMA increases the kinetic energy. Momentum. The decrease in IMA increases the momentum of the bike. Conclusion. The experiment confirms what I said in my hypothesis. A decrease in IMA increases variables like speed and velocity but doesn't affect the energy of the bike. Although the decrease in IMA increases the speed and therefore becomes more efficient in time, it requires more power. Now let's look at the graph of our results. This is a graph that shows the relationship between the speed of the bike and the IMA. As you can see, as the IMA increases, the speed steadily decreases. This is the velocity graph. It shows the same relationship as in the speed graph. As the IMA increases, the velocity steadily decreases. Next is the kinetic energy graph. In this graph, as the IMA increases, the joules of energy decrease. The next graph is the momentum graph. It shows the same relationship as the past three graphs. It also supports the law of conservation of momentum, which states if no net force acts on a system, the total momentum of the system does not change. Last of all is the energy graph. As you can see, there is no change in the energy despite the change in IMA.